Okay, then good morning, everybody, from my side. First, my name is Thomas Heber from Composites United. I have the honor to introduce our speaker today for this web seminar Wednesday in Composites United. Nice that you are here. And today, while few people are still joining us, I said it already, for this web seminar Wednesday. At first, we will have half an hour, a quick presentation of our speaker, and afterwards, you can, tell our questions, and we can have a nice discussion. I have now the pleasure to introduce you to Lucas Ciccarelli. Hello, Lucas. Nice to see you
Morning,
again.
Thomas. Hello.
Lucas, you are head of or managing director, let's say, from Alformet GmbH. Alformet, what Alformet is, you will show us in a few seconds. Let me say just before that you have a vision to commoditize tubular thermoplastic composite products. And how that will take place, how that will happen. We are curious to know in a few minutes. The stage is yours, Lucas. I'm happy that you are here and see you in a few minutes for the discussion then. Okay.
Pleasure, Thomas. Thank you for the introduction, and thank you to Composites United that I'm allowed to be here. So, getting started. To introduce myself, as Thomas mentioned, I'm the managing director of Alformet. Alformet is a producer of continuous fiber reinforced thermoplastic composite components. I myself am a mechanical engineer with always a focus on composite materials. My bachelor in Philadelphia, my master's in Aachen. My focus was always on the process improvements around around composites in general. I settled into thermoplastic composites. I've been about 6 years by AFPT, about 2 years now by Alformet, and during my time, the one thing that I always wanted to do is make myself redundant in the company. The task that I do, I always wanted to find my best way to program the intelligence somehow to make it easier to do the work and to focus on bigger and better things. And so that's how I would like to lead into the introduction. The name of the presentation today is No Sales Engineer Required, how you could access the thermoplastic composite tubes without having to go through a complicated engineering and sales process. As Thomas mentioned, what Alformet is there for is to lower the bar of entry for thermoplastic composite tubular products. So we want to commoditize these materials to make them more accessible, shorten the path to development, and then replace traditional solutions. Alformet stands for Alternative for Metal. This is something we do with our business model. Alformet was designed from the ground up as a company who uses the machines from AFPT and everything around those machines, everything about our business, from our inventory, our supplier relationships, our process flows, our ERP system, our company culture, is designed around the production of these thermoplastic components. So when someone comes in with something they want to have, then we help them design it, they order it, we manufacture it and deliver it. There's two sides of that business. For one side, there's the series production. That's when someone has a family of products that they always order the product numbers from us. And then there's the one-off production. And that's going to be our focus today. The one-off production is then when everyone wants to, that's high mix, low volume production. That's when every product is different and the products probably aren't going to be repeated. And our goal here is to optimize this top part of the process flow. So shortly about us, we're part of the AFPT group. And being so, I've already mentioned, we use AFPT's machines and technologies. AFPT has been focused on thermoplastic production with a laser since 2003, so now over 20 years. We have 5 machines at our facility here at Alformet that allow us to do so, process around about 500 kilometers of tape a year, and stay closely connected to AFPT and the current availabilities of functions on their machinery. For those who don't know, really short, the laser-assisted tape wanding process is a process that uses a laser as a heat source to melt the tape, both the incoming tape and the already laid substrate, in such a way that it's a closed loop control. It's melted completely when it gets to the point below. Then when the roller goes over it, it's a fully consolidated composite. There's no need for any sorts of post-processing. There's no need for harsh chemicals. There's no off-gassing. It happens in situ. It's quick, it's efficient, and allows for a scalable, high-quality production. At our facility, we have our machines. We have specialty temperature-controlled winding and placement equipment. We have several ovens and demolding stations, ranges of products that we could do. I'd be happy to let someone know about more when they want to know, and can achieve small to medium series size production at our facility currently. Primary product focus is thin-walled inserts, thick-walled structures, pressure vessels, and functionalized tubes. Those are the four categories I like to separate them on. The thin-walled inserts is things like rotor sleeves, things like localized reinforced inserts for injection molding processes, preforms for other post-forming processes. And then on the other side, we have the thick-walled structures, which are for rocket structures, for seals, for bearings. Those are our two bread and butter businesses. They're complete polar opposites. The one side is very high automation and low production times. On the other side is very long production size and very low automation. The pressure vessel is something I'm not going to focus on right now, but that's something that's also a very hot topic with the hydrogen economy. And functionalized tubes is also a very exciting topic, but not the focus of what we have here. That's taking the advantage of the full abilities of thermoplastic composites, be able to reform them, to bend them, to overmold them, and functionalize them into integration to other structures. The focus today is going to be specifically tubes, standard tubes that are straight, that have a defined laminate structure, that are tailored to the needs, and are made in the volumes and sizes that are necessary. So we're starting to get into the meat of what I want to present here today. This is a image of our digitalization map, the parts of the process where we are active in trying to digitalize our technology to reduce friction in the system, to make the system more intelligent, less potential for failures, and then have everything be able to be connected to each other and traceable throughout the entire process. So what I'm going to present to you is today what we're going to do on the front side of the process, but I'll speak a little bit of what else we have going on. In production planning, we have our own internal system and software that we programmed and use ourselves. That way, when we get an order, we are able to, with very few variables, give those into our system, which has the intelligence of what we know about how the different materials function, about how we know how the materials function in different conditions, being different diameters or angles of the mandrels, and then the different tooling that we have with the different abilities that they have. That on top with knowing our machines, knowing the geometry of our machines, and knowing the control system of our machines, by putting in a few variables, these software that we have automatically prepares a production for us. That automatically gives us the robot programs to be put on the machines. That gives us the production documentation and allows, with very few clicks and basic information, to set up a production so it could go in and either go directly to the machine or go to an operator to be entered into a machine. In the factory itself, we have several machines here, so we always need a way to have an overview of what's going on in the machines, what machines are doing what productions, what machines have the higher usage rates or downtime rates. We use primarily our ERP system for that and are building up a bigger system to really encompass the specifics of our machines, including our data loggers that we have on the machines. It's a product from APT that during the production logs exactly what happens. And I actually have one that I could show for you. I switch my screen very shortly. This is an active production. And luckily, there's very little to see here. So what's happening is that by every event, there's...
Lucas, yeah? we can only see your slide 10.
Oh, I didn't click. release. Thank you for that, Thomas. So as mentioned, luckily there's nothing to see here. What could be shown here is that when there's some sort of variance in the production, there's a warning of a sort. So there's either a yellow warning or a red warning to when anything about the production falls out of the limits. And the specific limits are set up for the specific products that are being produced. So when there's a family of products that we have, there's specific limits that are assigned to them. These are monitored live during the production. As mentioned, this is happening currently. Every minute or so, a new layer comes in. And then after the production, you generate such a certificate to show the customer exactly what happened on every layer, with what angles, what temperature, what speed, what force, and then a statement of compliance for the limits that we use to check this, plus then standard information to your order. So switching back to the presentation, Thomas, I know you let me know if something didn't work on the switch. Yes, that's what we have. And so that's on what happens during the process. That's what happens after the part is produced. Then you get a certificate out of the production. And then, of course, then there's the post-production. That is that we could use also the data from the machines to do either preparation for post-processing of machining, of anything to improve the product in a certain way that's either with surface or something specifically for finishings. And then there's also the diagnostics. So during the process, everything is recorded, everything is logged, everything is saved, and that could be used for very intense diagnostics, such as what we use with the partner in our joint venture, Digital Composite Factory, the company New Frontier Technologies, could, for example, use these diagnostics post-process to feed back into the machine and improve the quality of the product as we go along. So, as mentioned, a couple of times, the point of today is making the start of the process easier, reducing the time from, hey, that sounds like something interesting I want to try, to here's something on my table that I could get an impression of what it is, or at least test it directly. And that is showing, I decided to present that in a flow. When a typical sales order comes in, or a request for a product, there's a couple steps that need to happen. So before I even get into the whole process, even just between this first interface between customer and the engineer, a request comes in then over or per email. Someone says, I'm interested. I would like to learn more. And I'll say, okay, thank you for writing to us. I would love to talk to you. Let's set up a meeting next week. No, next week's not good. Let's try for the week after. Okay, we'll do the week after. Good. Then we have a meeting. We discuss the necessities of your applications. We discuss the design criteria for the process, talk about a little bit of what needs to be considered within the design criteria. And then they say, great, I would like a quotation. Good. Then comes into the pile of quotations that need to be processed. Might take some time to get processed depending on how capacities are. Then after that, a quotation is sent. And then the questions start coming, oh, what if we change this? So I want one more of those. I want an additional layer. What happens if we change the angle? Yes, good. Okay, recalculate. Here's the additional quotation. Good, then it needs to go into our processing, get ordered. Good, it's ordered. Goes to the machines, then goes to the machines, gets sent. Maybe from start to finish, 4 months go by before the first product is on the table, and we have a way to talk about it. And then what happens in between as well. So when we achieve this very long cycle of customer sales engineer, then after the order is even given, then the sales engineer puts the order into the ERP system. The ERP system is then forwards the manufacturing order to the production manager. The production manager prepares his production documentation, which at least is automated. He doesn't need to spend much time on it. The production documentation then goes to the operator, and then the operator needs to put the information in the machine. There's a lot of interfaces there between man and machine. There's a lot of ways where the same information needs to get touched again. There's a lot of times where there's necessary but unnecessary cycles of information that go through with questions and yes for updates. And what we are trying to do here is what we are doing here, and what I'm presenting to what we're doing, is we're gonna reduce this cycle to the customer puts in what they want in the configurator. There's somewhat of a feedback for a configurator system that guides them through the process of designing a tube. And then when they click order in the system, and they can pay right directly in the system, that could connect then to the production preparation documentation, as with this automated production preparation software, and then be put directly on the machine, waiting for someone to click start or get the material from the inventory and start the production. And that is what I would like to introduce to you now. I'm going to switch my screen one more time. And show you Alformet's new web shop. So this is going to be going live in a couple of weeks, sometime at the beginning of July. You'll be receiving you'll be seeing a press release in Composites World, and hopefully with Composites United, letting you know when it's live. Then whoever would like can go onto our website and start designing their own tube according to their applications. And so I'm going to walk you through about what we have here and show how the system helps guide you through this whole design process. So it starts simple. We have length of a part, put in a length of 250. We have amount, I'll say we're like 4. Here I say, here's an option to have a production certificate or not. There's an additional charge per production certificate, so you could have the option to put it there if you want to or not. And you could also add any additional information. So things you have wished, if you want to have contacts for post-processing, if you want to have a contact for what it would look like in series production, whatever you want, it comes in with the order. Going to the next step, it gives the option then to choose the winding mandrels that are directly available for use. There are other sizes available. There are other sizes that can be quickly attained. That's why we have a link here to contact us for when something here is on fit. There's a large list from about 20 up to enough up to about 270 is the list that we have here. And so you could then select your diameter, go to the next step, and then we get into the part where you choose the material. When choosing the material, then there is always considerations that need to be made of sometimes someone knows exactly what they want, then they have to go through and find it from the list. There's a large combination of polymers, of fibers, and of widths of material. There are explanations here explaining to you what goes into the process of deciding, and also short descriptions for each material of basic information of the fiber content and the actual width range, the price range, and the performance. And when going through the process, you could click, for example, here, I need help choosing my polymer. You go to our website, you could go see here where there's several different polymers, and you could click through, see what's there, learn about it, go back, make your decision. And the same is true, for the fibers. Same thing, there's a page on our website that explains the different fibers and how to choose one for your application. So going through, I would like to then choose a polycarbonate with carbon fibers, narrow. Oh, sorry. What's also here built into the system is letting you know when certain things are not possible. So if I try to choose a wide tape in this scenario, I already chose a 20 millimeter mandrel. A wide tape cannot be used on a small mandrel for the fact that the material doesn't drape over the process, doesn't drape properly over the mandrel, and you don't get a proper consolidation. So this is guiding you through the choosing process. Naturally, if there is the ability to choose between wide and narrow, the wide will always be the more cost-effective choice because that's more per material per minute that gets placed in the process. So here we choose the polycarbonate, go to the next step. And then here in the next step is where you could start configuring the laminate layer by layer, step by step. So we have instead of breaking it down by steps, we have it broken down by layers, which gives the ability to, other way. Instead of breaking it down by layers, we have it broken down by steps. Therefore, you could then choose multiple angles and choose how many layers you want to have that angle. And then also choose then between the winding types. In our process, there's 2 basic winding types. You call them angle winding and cross winding. There's a short explanation here, and there's documentation that's not finished. That's why the link's not there, but it's being prepared where then here's the link, and you could find out more information about what it means to choose one or the other. There's quality considerations, there's costing considerations, there's productivity considerations, there's things that go in that'll be explained to you. That way you can then make the decision yourself. Here you could, so I'll say I want to have 1 angle layer of 89 degrees. And what that does is it shows me then directly the effective layer that comes out of the process. That gets back to then another important thing that someone needs to know about the thermoplastic tape winding. We lay the tapes over a mandrel in such a way that a layer is completely closed. That means depending on the diameter of the tube and on the width of the tape, there's only certain angles that are possible. Not every single angle is impossible. And then here you could see what is the effective angle that comes out of the process based on the desired angle that you would like to have. So that I just define one layer. As you see, the price starts forming. It seems quite expensive for one layer, but here is where you can see then how much of the price is then going into the basics and the setup and the secondary time, how much price is for the part, how much price is the material. These are things that we could play with here and see because it all updates live at the top of the page with the information about the diameter, the weight, the thickness, then the price per part and the total order price based on the number of parts that we've selected. So going through this process, then I would like to have some cross layers for about, I'll say, 4 layers here. Here I noticed that I write here that cross layers are always a combination of 2 layers because cross layers weave 2 layers into one. So 4 layers in this case means 8 layers below. And I would like to have that with, 4 cross layers means 8 layers. And I would like to have that with 40 degrees. I select that. And I see what are the actual angles that come out of the process again. So this can be played with back and forth. We could watch the price update, and we could also then see how we optimize. So if I see here that I want to then get more out of a production, because I noticed that when the part is much shorter than the mandrel, then the more parts that fit on the mandrel, the more the price comes down. So I can then click right back. I got to change this to 8 parts, refresh. The price per part, excuse me, I didn't look at it myself. The price per part was 68, and I put in 8, and it comes down to 43, and so forth. And the same with changing if I lower the length per part, then obviously the price per part goes down. If I increase it to a certain point, it might tell me, oh, that doesn't fit on the mandrel. Those things also come into play. I could say, no, I want 1 meter 5, and it starts updating. Now it gets much more expensive because then there's less parts that could fit on the mandrel per winding. That's why the part for price shot up then at this point. So we'll go back to that. And then could also show you then one could see how the different diameters affect this mix here. So you could choose a larger diameter. I'll go for 110. And then we could see then here the wide tapes and the narrow tapes are both available. So we could then see here, then here's a narrow tape. It's 109 per part. I choose a wide tape in this scenario. It's a little bit more cost effective. How much the tape and the width of the tape actually impact the final price of the part is then once again very dependent on how many layers we're actually putting into this part. Oh, and here you could continue adding steps as far in as you want to go. I could add then another step for another 15 layers of angle winding, and it goes on and going back and forth to design exactly what it is that you want to have in your part. And this is this constant feedback, which has always been missing for the potential consumers of this technology, where they need to be discussing to someone who is an expert on this, who can both advise on the financial aspects of it, as well as advise on the engineering aspects of it. And this technology itself, so thermoplastic composites themselves aren't widely used. The technology of laser-assisted tape winding is also relatively young. There isn't a general understanding in the zeitgeist of the market how exactly this works. And that's what we want to provide. We want to provide a way that not only provides easy access to this material, but also education on how it works, why it works, and how you best optimize it for yourself, your application, and your company. And it's obviously, these are not volume prices. These are not going to be something that you could expect for 1,000, 100,000 parts. It's not even possible to order here. We're talking in range of here, maximum 50 parts currently. And what that means is that also the tape prices and the tape availability, these are also not the most optimum prices, but it allows an easy way to get access to it, to try it out, to validate for the application, and more quickly, when it comes to it, move to a state where you could be ready to either order more variants and try different things out, or get closer and closer and closer to getting to that series application where you could then be ordering in large volumes, have the potential, have the prices. This is shortening the loop, closing the circle, making all of our lives easier. So obviously then when it's finished, click on complete configuration. You see a short summary of what your price per order is, everything you've chosen here. Go to your summary, you put it in the cart, you go to checkout, you order it, you have it in a few short weeks. So for me, that is the core of what I want to get to here. I wanted to show you who we are as a company, what does we do, where our core capacities are, and where our value is. Our value is we have an incredible amount of knowledge. We have quite an amount of capacity on our machines. We have very good relationships to suppliers of not only the mandrels, but also to the tapes that we have, a consistent stock that's been built over time, as well as channels to quickly acquire more things that are necessary to more quickly get you what you need to try it out and getting something on the table to feel it, say, okay, that's what it looks like. That's what it feels like. That's how it's going to work in my application. The next step of that is then the digitalization. We have now the potential to give the configuration abilities directly into the hands of the customer. There's obviously those buttons to reach out to us if something's not clear or something needs to be explained in more detail. And there's also, for example, a save button on the page where you get an email link of the thing that you have configured. You could then forward that that link directly to us and say, hey, I'm having problems. Can you help me? We could adjust it for you and then send a link back for you to proof it, order it, and moving forward. I hope you've enjoyed the process this presentation itself. I hope you use our system when it goes live. Like I said, stay tuned and look out for it. And honestly, I would like to then do less talking for the presentation itself, open the floor for more questions, and discuss any feelings you may have, as well as also give you the potential to help form the future with us. When you have input, let us know. When you see something that information is missing, say something that seems unclear. Obviously, we do this every day, so it's easy for us to oversee something. Reach out to me, let me know. I'd be happy to implement your opinions.
Okay, thank you very much, Lucas Ciccarelli, for this nice introduction and shown technology, and especially how you make for us the technology easy accessible and much easier than before. Because for me, I like clicking through configurators, and to see what happens and what they are doing. Okay, thank you very much.